So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about curves and Onshape. So, we're going to discuss all the various curve commands that we have in Onshape and ways that you can use them, places that you might use them. Now, as I always say with these webinars, we really encourage you to ask any questions that you'd like. There's a questions dialog there in the GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and answer the questions as we go through today's webinar. So again, topic today, creating curves. We're going to focus really on 5 commands and all the various curve commands that we have, and again, where you might use them. So let's dig in. This is going to be a short webinar. We're really just going to focus on those 5 commands and a few different examples for them. So as I mentioned, I'm going to introduce you to the curve tools. We're going to discuss the various curve tools that are there, and we're going to discuss where they're used, where they're applicable, and how they can really make especially smooth curvature very easy. And so especially important if you're creating more organic shapes, more complex shapes. These curve tools we're going to discuss today can be really valuable to you. So we're going to introduce you to the curve tools. We're going to discuss where they're used and then, of course, show you examples of them. Again, feel free to ask any question. There's a questions section there in the GoToWebinar control panel, and I'll answer them as we go through things. All right, so what are the curve commands in Onshape? Now, this is something that's grown quite a bit over the last 4 or 5 months or so. So if you've been watching Onshape, if you haven't used Onshape in a while, realize a lot of these commands I'm going to show you here today are new. Unless you've been actively following, you'll know that we just added a whole bunch of new curve commands: projected curve, bridging curve, composite curve. All relatively new. So what are the various curve commands? Helix, that's the most common, of course, and the most used. It's been around the longest, and as you can imagine, used to generate all kinds of different helix-driven shapes, things like springs and threads and so on. So helix is the first curve that we're going to discuss here today. Then we're going to get into bridging curve. And like the name implies, it's a useful tool to create a curve that bridges 2 pieces, 2 parts, right? So bridging curve, very useful in that kind of scenario, especially if you're creating fills or lofts for more complex shapes. It can be a very valuable tool. The next one, projected curve. This is another scenario where you're using, in this case, 2 sketches to create a complex 3D curve. Right? And it is essentially the intersection of 2 sketches that you get that 3D curve. And I'll show you an example of this in just a bit. The next one I want to mention is composite curve. And the way to think of composite curve is a combination of entities, a combination of things. So if you ever had a scenario where you want to create a loft, or I want to create something where it's a combination of entities that I need to select, I would create a composite curve out of them. And again, I'll go over an example of this in just a bit. And then a 3D Fit Spline. That also falls in that category of a curve, and that's the last thing we're going to discuss here today. The thing that's unique about 3D Fit Spline is you essentially tell it, here's the points that I want my spline to pass through, and you can define how its start and end direction is controlled. And the neat thing about that is you can align it with surrounding edges. Again, a lot of these commands are really about creating smooth curvature, smooth transition between shapes, and 3D Fit Spline is no exception, right? It has the ability to match those surrounding edges. So these are the various curve commands that we're going to talk about here today. Again, helix, bridging curve, projected curve, composite curve, and then finally 3D Fit Spline. So it's going to be a short webinar. We're really just going to walk through examples of these. Again, feel free to ask any question that you'd like there in the questions dialog in the GoToWebinar control panel. So let's dig into it. Now, the first one that I want to start with is the most common, and it's probably the one that we get the most questions on. So I want to start with the basics. And when we talk about basic curves, the simplest curve is a helix. Now, like you can imagine, a helix is useful in a number of different scenarios, like springs, like you can see in the screenshot there, or creating threads, for instance. If you actually want to model a thread on your part, you would use a helix to do that. So there are a few common examples. I think springs are probably the most common. Now, keep in mind there are lots of ways you can use helix, but I think springs and threads are going to be, 2 kind of quintessential examples of the helix command. Now, the key with the helix command is you can use either a construction cylinder, a 3D model, a 3D cylinder, or just a circular edge to create your helix. And it all depends on how you want to define your helix. A lot of people like to be able to just extrude a cylinder and say that's the length of my thread or my spring, and then just reference the cylinder to create the helix. So I'm going to go over an example of this in just a bit. Of course, you define the helix based on the number of turns or a pitch. So it's up to you how you choose to define it. Again, ideal for things like springs and threads and so on. So let's get into it. Now, the helix command, again, the key thing that I want to stress with the helix command is you can use multiple different techniques to create a helix. It's not just one method. A question that's been asked is, how about a conical helix? Absolutely. You would use a conical cylinder shape to define the actual helix. So in the example you give is a perfect one. Pipe threads. Pipe threads are tapered and therefore would need a tapered cone to define the helix definition. And you can do that. Now, this is, let's get into the example here. This is an example where I've used a construction cylinder, a solid cylinder, to define the length of a helix and then define the actual diameter also of this with the helix. So it's a very easy way to simply say, here's the diameter and length of my spring or thread, right? So let me show you how this works. Let's go ahead and delete this sweep for the spring, and we'll delete the helix and the sketch that go with it. So at this point, it's just a simple circle that's been extruded, right? A simple cylindrical part. And what I've done here is just defined the diameter that I want the spring, right? The center profile of the spring, and then the depth that I want the spring. How long do I want the spring with this cylinder? Now, this is just one technique, but it's a common one in applications like this, because now all I need to do is select the helix command from the toolbar and then left click the actual face of the construction cylinder, right? So here you can see it automatically grabs the diameter, and then I just have to define, how many revolutions do I want? What is the start angle, so to speak, right? So just keep in mind, this is just one technique. I'll show you another one in just a bit. But it's an easy way to define both the length of the spring or thread and the diameter of it. Now, I mentioned before you can define by turns or pitch. There's options here at the top, right? So when you use a construction cylinder like I have here, you have turns and you have pitch, right? Like the names imply, you're defining the number of turns over the length or the pitch between each, right? Now, when you get into height and turns, height and pitch, turns and pitch, these are when you reference circular edges, not cylindrical faces, because then you have to define the length, right? So just keep in mind, turns and pitch, you'll use those when you've used a construction cylinder like I have here. I can just click the edge or the face that defines it. However, let's X out of this, jump back into the command. I can also do something like height and turns and define a cylindrical edge, right? So maybe, I don't want to go through the effort of actually extruding a cylinder just to create a helix. I can just sketch a circle, or I can just select a circular edge of something that already exists. Especially useful if you're creating threads, because oftentimes you start with that major diameter and then you want to cut the threads, which is essentially an example like what we're doing here. So again, the height and turns, height and pitch, these are just different ways of defining the helix. But those last three options assume you're using a circular edge and not a cylindrical face. So then you'll have, the height of it, right? So I can input the height, how far I want that thread or that spring to go, right? Whereas the first two options, that's defined by the length of the cylinder that you click on. So that's the helix. And again, the example I would often give there is springs and thread definitions, where you're creating a sweep that follows that shape, right? Question: how about starting the helix at a point instead of at an angle? You can't. There's no option to do that as of today. Right now, and this is a good point to mention, this is a common thing that comes up, is when you create a helix, it has what's called a start angle. There's no way to define by point or any other reference, and it's somewhat arbitrary. So the thing I would point out is it's generally aligned with default planes if it can. So, if I turn on the front or the top plane, you can see that this helix starts right at the center of the part or the top plane, right? So, but keep in mind, you can set this. Let's say that I wanted to start at the right plane, for instance. I can punch in 90, hit enter, and it's going to rotate that helix around till it starts at 90 degrees from that last position. So you can adjust it, but you can't add a point or something as a reference. Okay. Can be designed multiple helixes for threads, sure. And if you have multiple starting points for your threads, you could just do multiple helixes at different start angles. That's one way to accomplish that. I've seen it accomplished. But absolutely, there's no limit to the number of helixes that you can create in a single space. Right. Okay, so again, keep in mind when you're generating that helix, you can use a cylindrical face, you can use a circular edge, or even just a circle sketch to define your helix if you want to. It's all up to you. You can define by turns, you can define by pitch. Again, that's up to you as well. All right, so that is the helix command. Let's jump into the next one. The next one on my list is the bridging curve command. Now, the bridging curve command is very valuable in a few specific situations. I think it's most applicable in scenarios where you're trying to create a smooth transition between two different things. So, I've modeled, this piece of a part over here and this piece of a part. Now I got to create this bridge that joins the two pieces together, and it's important that that bridge transitions smoothly, right? That I don't have any sharp corners in this transition between the shapes that I've already created. So that's an example where bridging curve is really valuable because you can create a loft, right? I can create a filled surface, but oftentimes I may not have everything I need just by selecting edges. And that's an example where bridging curve can be really valuable. So again, think of any scenario where, I've got pieces that are right now separate. I'm trying to create this feature that joins them, and I need a smooth transition between those two, right? That's an example where I might use bridging curve. Now, the example I have for you here is, let's say that I'm designing a bike frame, and it's a road bike frame, and curvature and smooth curvature is very critical, right? For a lot of different reasons. So I would want to make sure that when I create a fill or when I create a loft, that it blends smoothly with the surrounding faces. All right, so the big thing with the bridging curve, again, keep in mind it creates a curve between two selections. Now, you can just create a curve between 2 points. So if all you're looking for is a simple straight curve between 2 points, bridging curve works in that scenario too. But I think it's most valuable with an option called match tangent, and it allows you to match that profile. A question, conical helix. Yes, this was asked earlier. You would just simply use a conical shape, a conical solid to define your helix, right? Just select that face as your definition for your helix. If you stick around for the end of the webinar, I can model something up quickly here and give you an example. All right, so bridging curve, as I mentioned before, I think really useful if you need to cleanly blend surfaces and get a smooth transition. So in this example, I have a bike frame, and I need to create that smooth transition between the top tube and the seat tube of this bike frame. And what I want to do is I want to loft between an edge here and an edge here. But if all I do is just loft, and I select my surface and I select those edges, I'm going to get this sharp transition between them, right? I will get a loft, but it's not smooth, and matching those surrounding contours. It's certainly not the smooth transition that I'm out to get. You can see basically a sharp corner here that I really want a smooth transition. So again, I can use a standard loft, but I want to be able to control the shape a little bit more. And one easy way to do that is by defining bridging curves between the shapes first and using the bridging curves in this example for guides in our loft, right? So first off, the bridging curve and basically all the tools that I'm discussing here today are under this helix drop-down menu. So this icon will change depending on what you've used last, but by default, I think it shows a helix, and you're going to see 3D Fit Spline, projected curve, all the commands that we're talking about here today. So let's discuss the bridging curve. Now, the bridging curve, pretty straightforward. You select two things, it creates a curve between them. How the curve matches surrounding geometry is up to you. You can create a simple curve that doesn't isn't worried about matching tangency by choosing the option to match position. Right? So in the drop-down, there's an option to match position, and all I need to do is click 2 points. Right? So click the second side, click the second point, and it creates a simple bridging curve between them. So if I'm not concerned about matching tangency and smooth transitions, this is a solution, match position, right? If I'm just looking for a simple sharp transition. However, I think the power of this command really comes in with match tangent. So under the options, you'll see match tangent, and like the name implies, it allows you to match tangency with whatever you select. Now, the key difference here is you wouldn't select a point. You would select an edge, right? So I want the curve tangent with this edge and this edge, right? And what you'll see is it creates a bridging curve that joins them that has a smooth transition, and that's the most important thing. Now, I can adjust the magnitude of the bridging curve if I choose to, and I can even adjust the bias, up and down, left and right, if I choose to. Okay. So just keep in mind it's an easy tool to create a guide for a loft or an edge for a fill, right? Because I don't have to spend a lot of time on it. It's simple to do. I can hit the green check OK, and now we have one piece, one guide in our loft. Now I'm going to do this one more time, so bear with me. We're going to select bridging curve. We'll select this time this edge and this edge. And again, we get that smooth transition between those edges. And now I've got these lines, these curves, I should say, that give me the guides for my loft, right? So when we go to do a loft now, we can choose our loft, select each edge, right? And then add the guides that give us that smooth transition that we want, all right? So this is just one example. Another very common example of using bridging curves is creating edges for a fill, because it's a very similar scenario. You kind of need to fill this gap, and you may not have a clear boundary for a fill, and you can use bridging curves as a way to fill in those pieces that you need to get that boundary. So that is the bridging curve command. Again, you can just do simple bridging curves between points, but you can match tangent if you select edges, and it creates that smooth transition that can be really helpful in these kinds of commands. All right, so quick question. Can bridging curves be used with other modeling functions besides loft? Yes, absolutely. Fill would be the other common there. I would say they're both equally common. I could see other scenarios where it could be used, but I think 90% of the time it's probably going to be lofts or fill. Just because of the nature of it, just because it's intended to bridge two things and fill that gap, and there's not a ton of other commands you would use in that scenario. But I could be wrong. So, all right, so that is the bridging curve command. Again, keep in mind it's great in these kinds of scenarios where you're trying to join two things and create a smooth transition between them. Let's move on. Now, the next one in our list is projected curve. Now, projected curve is really a 3D curve at the intersection of two sketches. So if you were to take two sketches, on different planes and extrude them until they hit each other, that 3D intersection is what a projected curve is. That's how it's created. So, think of it in any kind of scenario where you're trying to create a complex 3D curve that's really just a combination of two different curvatures, right? Two different, 2D curvatures. The example I give here is the toothbrush that you see in the screenshot there. And you can see that it's a 3D curve surrounding the outside edges of that toothbrush. That 3D curve is just a matter of, two sketches that were combined into one projected curve. Then that projected curve was used as a boundary for a loft or a fill, right? So let's get into it now. Again, a projected curve, remember, it's a curve that's created at the intersection of two sketches, which means you need two sketches to create this. And very similar to the last command, very useful in a number of different situations, but especially so for loft guides or edges in a fill. So again, a lot of these commands that you're seeing here today are very much about smooth curvature, more complex shapes. So let's get into it now. The toothbrush is actually a fairly straightforward example. And it starts pretty straightforward as well, right? It's just a combination of two sketches. So if we look at this toothbrush design, and you can see this projected curve 1 in the feature list here, which is just the outside edge of that toothbrush. If we roll back to this point in the design, you can see it's just two sketches, right? I kind of have the outside shape of the toothbrush and the contour that I want the toothbrush to follow. And the outside shape is going to be a combination of essentially this and this curve, right? It's going to be where the two meet, right? That's where we get when we select the projected curve. Again, you'll find the projected curve under the same drop-down that we've been showing throughout the whole webinar here today under Helix. You'll find projected curve, and it's just a matter of selecting your two sketch entities. Again, this command needs two sketches, right? So we'll choose the top half, then the bottom half, and what we get is a 3D curve on the outside of that toothbrush profile, right? So if I hit the green check and we hide a couple sketches here, you can see we have just that 3D projected curve that is, the outside shape of the toothbrush. So again, if you think of this as a way, I take one sketch, I extrude it, I take another sketch, I extrude it, where they meet, that's a projected curve. And so that's how you get the shapes that you see here. This is an example of where a projected curve would be useful. This is one. I have another in the webinar mouse, which is a public model, I believe, where you're trying to create the outside contour of a loft, and it's a 3D curve, and you create a projected curve to do that. Lots of different examples. If you stick around, I can call up another one if you'd like. All right, so again, a projected curve in this example is giving me that outside shape of the toothbrush that I then use later as maybe an edge for my loft or an edge for my fill. So that is the projected curve command. Again, think of it as just an intersection of two sketches. The next command that I want to discuss is composite curve. Now, composite curve, it's a composition of multiple things. So, think of any scenario where I've tried to be able to, maybe create a sweep, or maybe sweep's a bad example, but a loft, and I want to follow guides, but the guides are a line, arc, line, arc. It's a combination of things. Well, if you've ever tried that in Onshape, you'll know that you can't just select a combination of entities and say this is one guide. What you have to do is create a composite curve, bring together all those lines and arcs into one selectable entity, and then use that selectable entity as your reference for whatever command that you're trying to create. So the example I think is most common, at least the question I think this answers for most people today, is, how do I take a combination of lines and arcs and use it as guides for a loft, right? Today, right now, you can't do that unless you create a composite curve, right? So it's great for defining loft profiles. It's also great for defining guides for a loft. And, it's useful if you need to take a combination, and it could be a combination of, edges of the model, other curves, sketch entities. It could be a combination of any of these things and make it into one selectable entity, right? So let's get into an example of this. The example I have here is the spray nozzle, and I like this example because there's lots of situations where I'd want to select just a couple of edges and loft between another couple of edges, but not everything, right? And in those kinds of situations, that's where you would use composite curves. So let me give you an example. We're modeling the handle for this. So let's roll back to a point in this design here. So I want to roll back to a point in the design in the handle. Right, so we'll roll back to this point where it's just a surface, right? It's just a lofted surface at this point. Now, what I want to do is enclose this surface, but I need to create a loft for the top half and a fill surface on the bottom half. So, I need to create a loft out of this edge, and this edge. and I need to loft to the other side, this edge, and the same edges on the other side. Now, if I just choose loft and I select surface and I just start selecting edges, I can do one loft at a time just fine. But I can't start selecting multiple edges and then try and loft between all of them. So essentially in this example, I would end up with 3 different lofts. Now you can imagine if your example has dozens of lines and arcs that you're trying to follow, selecting them one at a time certainly isn't an option. And it may not be an option at all if this were a guide rather than a profile, right? So how do you solve this problem? How do I create one loft that's comprised of all those edges? And the answer is to create a composite curve. So I choose composite curve and I just select the edges. Now remember, this could be edges, this could be other curves, this could be sketch entities, and it could be any combination of those things. So you're not really limited in what you're allowed to choose. And essentially what it gives you is one selectable entity, right? So now if I look in my list here, you can see curve 4, and curve 4 is just those 3 edges. The reason this is valuable is now I can go to loft and I can just loft between those 2 curves, right? So curve 3, curve 4, and now I'm creating one loft that encloses that back piece of the handle. I don't have to do it 3 different times. I've got one feature that does that. Now, this is an example with 3 edges, but I think very common in examples where you have dozens of edges, and it's just not practical to do them one at a time, or it's just too tedious, right? This is an example where it'd be useful. So that is the composite curve command. All it does is it allows you to take multiple things and bring them into one selectable entity. Now, there's lots of examples where this could be useful. So, I don't want to say this is just applicable to loft or just applicable to fill. I could see other places where this could be valuable, something like even a sweep where I just want to make sure everything's clean and neat. I could create one composite curve of my sweep path and define it that way. So valuable in a number of different applications. But if you've ever run into a scenario where, I need to select 5 different things for my guide or whatever it is, and right now it only allows me to select one, make a composite curve out of it, and then use that as your reference. So that is composite curve. Let's move on to, I believe, our final curve in the list. It is the 3D Fit Spline command. Now, 3D Fit Spline is a curve. It generates a curve in your feature list, and it's selectable and usable in all the ways that the normal curves are. The thing that's really unique about 3D Fit Spline is it allows you to select a series of points. So essentially, you're creating a spline that passes through points, which is in and of itself pretty simple. The unique thing about this is you can define a start and end direction. And I think that's where it's really valuable, because then you can make sure that your spline matches the edges that it's attached to, right? It's a smooth transition from the edges that it's attached to, rather than just, again, those sharp transitions. So again, a lot of these commands are really about creating smooth curvature. So let's get into it. Now, the example I have is that same spray nozzle we were looking at a moment ago. So if we roll up just a bit further, let's take a look at how this bottom piece of the spray nozzle was constructed. And it was actually constructed using a loft. So if we roll back to a point in the design, you can see we have sketched a line that just represents the bottom of the handle. And what I need now is a spline that passes through this point, and this point, and matches these edges. So it's a smooth transition from those edges. And this is an example where 3D Fit Spline is really valuable. So I would choose 3D Fit Spline, again, under that same drop down in the toolbar. And I would choose my vertices, right? Again, you're just selecting points that you want the 3D Fit Spline to pass through. So point, point, point. Okay, and then you can see I'm given this 3D Fit Spline. It's just a spline that passes through those points. Now, you can control how this transitions from the surrounding edges. And as you can see, this isn't really a smooth transition. This isn't what I'm looking for. I want this handle to kind of extend naturally and create this smooth spline on the end. And that's where start and end direction become valuable. I can select a start direction, select an edge, and it will define that as a reference. Now, keep in mind, You can flip direction. You can extend the magnitude if you choose to with the direction arrows. But it's really just a matter of saying, I want my spline, adjoining edge. I want the adjoining edge to be factored into my spline. I want a smooth transition from that adjoining edge to my spline. So that is the 3D Fit Spline. It can be just a simple spline that passes through points if that's all you're looking for. Other applications I've seen for this were things like wires. If you wanted a spline for a wire, or if you wanted to generate a 3D spline for like an exhaust manifold like shape, right, where it's twisting in multiple directions at once. 3D Fit Spline is valuable there. So again, 3D Fit Spline, you'll find it under the same drop-down menu that we were discussing before. But the neat thing I always like to mention about it is the ability to define that start and end direction and to control it with the magnitude. All right, so that is 3D Fit Spline. Questions? I see I missed a few. How about controlling slope at one point at one of the mid pass-through points? There's no way to do that as of today. Can be modified as Bezier curves? No. We do not have the ability to modify these curves independently later. The only controls that you have are through the points and then the start and end direction. Pass-through tolerance envelope through midpoint. Pass-through tolerance envelope. I'm not sure I understand by what you mean by a tolerance envelope through midpoint. Forgive me. All right, so those are the 5 commands that I wanted to discuss here today. Again, just recapping them, jumping back to the top. Helix, by far the most common. Bridging curve, projected curve, composite curve, all relatively new commands, but very powerful, especially if you're trying to create more complex shapes. And of course, naturally, 3D Fit Spline, useful in all those types of scenarios where you're trying to create a 3D spline that's aligned with edges of your model, for instance. So that is what I had planned. I have one last thing that I want to mention before I move on. I am going to stick around and answer any questions that you have. So feel free to ask any questions there. And then go to Webinar Control Panel. I'll make sure to try and get to all of them. One last thing I want to mention before I wrap things up here. The question often gets asked is it possible to use an equation to create a curve? And I want to point out there's no button in the interface today, on Onshape's toolbar today that will do this. But you can do this. You just have to add a custom feature created by our own Ilya Baran. So Ilya is one of our developers. In fact, he manages all of our feature script, and he created this parametric curve feature, custom feature that you can add to your toolbar. So if you're at all interested in creating curves based on parametric equations, definitely check out this command. It's very interesting, and I know a lot of users have asked for this kind of ability, and I definitely like to point it out because, again, it's very simple to add this to your toolbar and start generating parametric curves. All right, so that is what I had planned. Again, I'm going to stick around and answer any questions that you have. So feel free to ask questions there in the questions section. Go to Webinar Control Panel. I will make sure to get to all of them. But that's it, everyone. Thank you, and have a good day.